Hello guys, welcome to the class CN 204 Mechanics Lab. Today we will do the experiment which is beam on two flexible supports. This is the apparatus, this is a roller, this is a roller, this is a flexible support that reads a unit force or reaction. Okay, this is flexible support. Okay, it moves up and down. This is a dial gauge that reads the deflection, okay, in millimeters. If you can see, every division is 0.01 millimeter. If you can see it, every division is 0.01 millimeters. It measures deflection. This is as well measures deflection or displacement. هلا in the first case, we will be putting a weight of 10 newtons and 20 newtons and eventually find the reaction over here. However, in each time, as I said, this is a flexible support, and let me tell you here, if I have this beam and I'm loading it from a place, it will move from the flexible support which is over here. So the system, I'm exaggerating, so the system will be inclined as follows, creating an axial loading. And since the system here is not equipped to find the axial loading, I have to remove it. How can I remove the axial loading? By returning back the system to its initial position. I will repeat. When I put a load on this system, because this is a flexible support, the system will be like this. I'm exaggerating. However, it creates an axial loading over the x-axis. I want to eliminate the force in the x-axis so that I will count for the y-axis only using this load cell. So I have to remove the axial loading. How can I remove it? I will bring the system back to its initial level. How much is the deflection at the flexible support? I can know it from the dial gauge that reads the displacement. I will return back the system by the same amount indicated by the dial gauge using this knob, as you will see in the apparatus over here. Is it clear? This is the knob where we will be using it to lift up the system back to zero by the same amount indicated in this dial gauge. We will start at X. We will start at X equal 100, which is over here. X equal 100 from the left support. We will recheck. Okay, it is 10. This is 10 centimeters or 100 millimeter from the left support. This is calibrated. Let me check over here. This is calibrated to 0. now we calibrated to 0. This is 0. This is calibrated to 0. You have to look perpendicular. You have to look perpendicular in order to check it up to 0. Now everything is good. This is leveled. This is leveled. Now we will put 10. We will put 20 newtons. This is 20 newtons at first. This is 20 newtons. Look at here. It is deflected by around 45 divisions. We will bring it back to 0 using this knob. If you can see, the other way. إذا كانت counter clockwise بنعملها clockwise and vice versa. Now the system is back to 0. Now we can read the force. It is 19.7. At x equal 100, force equal 19.7 newtons. We will take this and bring the system back. We will bring the system back to level. Okay. As you can see over here, I did this mark so that I will bring the system back to it every time I need the system to be in level position. Okay. Now we put the 20 degrees. I will bring back this to 0. Okay. This is 10. I will put 10 newtons. These are 10 newtons. I will put here 10 newtons. It deflected around 35. In this direction. I will bring it back. Now I can read. It is 10 newtons. It is 10 newtons. Okay, now, as we said, we will bring the system back to level. This is leveled back. We put this back to 0. Now, we will put this at x equal 200. X equal 200. This is x equal 200. We will recheck. X equal 200. Very nice. As usual, we put this to 0. We put 20 newtons over here. Bring it back to 0, please. عكس ما هي بتمشي. That's enough. Let me see over here. At x equal 200, f equal to, let me see, over here, read it with me. هذه 10, 15, 17.1 at 20 newtons. Now we will find at 10 newtons, but we have to bring the system back to level. Okay, we bring this back to 0. Okay, now we put 10 newtons. We put 10 newtons. We bring the system back to level. We bring the system back to level. Now we can read this. 9.6. 9.6, let me see. 9.6 newtons. We bring the system back to level, and we will continue in this manner. We will put x equal 300. Now it is 300 from the left support. From the left support. We put this to 0. Now this is it. Now we will bring it back to 0. Now we can read it. It is 14.5. X equal 300, F equal 14.5 at 20 newtons. Now we will put the 10 newtons, but we will bring the system back to level. This is 10 newtons over here. Okay, we will bring the system back to level. Seven newtons. Okay. Now we'll put it at mid span, which is 400. Now all these numbers are in case 1. All these numbers in case 1. This is 40. This is back to 0. Now this is at mid span. This is 20 newtons. Bring it back to 0, Mr. Rawad. Thank you for Mr. Rawad, our great friend, who is helping me now. Now we brought the system back to 0, eliminating the axial loading. Now this is 11.5. X equal 400, F equal 11.5 newtons. Now let's put the 10 newtons. But before that, we have to bring it back to 0. Bring it back to 0. Okay. Now, the 10 newtons. $5.5. Do you agree? Do you agree? Please follow up the the readings. I may miss some readings. Okay. Now we will put it at 500. This is 500. The system is back to 0. Okay. This is 20 newtons. Okay, now we brought it back to 0. It is 8.5. We have always to calibrate the dial gauge. As you can see, we will put it at 600. No, but not 500. We still in the 500. We have to do the 10 newtons. We have to do the 10 newtons. This is 10 newtons. It is 4 newtons when the load here is 10 newtons. We have to put it at 600. At 600 from the left support. This is 600. Now, now this is 20 newtons. This is 20 newtons. As you can see, as we move on the as we move to the right, the deflection here will be minimal, because the other support will take the reaction. .5 at x equals 600. 5.5. Bring it back to 0. As I said, when we go further on this apparatus, the deflection here will be minimal because it is more taken by this support. Halla, the last is at 700. This is at 700. Let me check from there. Yes. This is 20 newtons. This is 20 newtons. This is 2.5. 2.5. By the way, we forgot at 600 to put the 10 newtons. I will repeat after I finish here. Now, this is it. we will put the 10 newtons. It deflected like 3-4 divisions only. Okay. It is 1.1 at 10 newtons, 1.1. Let me put it at 700. This is 700. كنا هلا 700 لا على 600 and seen at 10 newtons. We forgot the 10 newtons at 600. Okay, هيدي اوكي هيدي 0 وهي 10 نيوتنز. هاي اللي كنا نسينا على الاكس ايكوال 600. اوكي it is 2.8 F 2.8 على 10 newtons. We finished. Now in case number 2 I will send you the all the details on your WhatsApp group, but in case number 2 I also send to you the equation. The equation is as follows. This is the equation. You can find it in the appendixes that I send you as well on your WhatsApp. Eventually, the E we will be using for this bar is 210,000 Newton per millimeter square modulus of elasticity, and I is 1/12 bh cube, which is the moment of inertia. And you already know that the moment of inertia depends on the cross-sectional area of the beam. The cross-sectional area of the beam is 6 millimeter by 2 millimeter. فبتعملوا a moment of inertia on the weakest axis تطلع معكم 360 millimeter 4. Okay? In the first case, we were finding the reaction after bringing back the system to its initial level. Okay? راح اعمل ريزوم. بالcase 1 كنا السيستم it deflects a little bit down because of this flexible support. In order to eliminate the axial loading, we will bring the system back to its initial level by the amount indicated by this dial gauge using this knob behind the flexible support. This is case 1. لقينا reaction. بالcase 2 we will find the deflection. هلا الايكويشن اللي بعثت لكم اياها, if you check it in the appendix, it will tell you that you can find the deflection at the points between 0 and L/2, based that you have the system simply supported beam having the load in the middle. فإذا بالcase 2 we will put the loading which is 20 Newton in the mid span. فصار عندنا simply supported beam, عندنا loading in the mid span, and we are finding the deflections at different points over the system. هلا الايكويشن هي بتعطيكم deflections between 0 and L/2. However, because the system is simply supported, you can assume that these the other values are the mirror. Okay, يعني الاكس at 300 مثل الاكس على 500. Okay, it is the same thing because we have a simply supported beam. راح يكون الديفليكشن in this way. فالديفليكشن هون رح تكون قد الديفليكشن هون. This is the 400. Let's assume عندنا 300. The deflection home must be the same as the deflection over here, but we will prove it experimentally. بالنسبة للإيكويشن الإكس هي مطرح ما عم تقروا الديفليكشن. X is the place where we are finding the deflection. P is the 20 Newton, the load applied. L هي the span between the two supports, which is 800 millimeters. E, as I told you, is the modulus of elasticity of steel, which is 210,000 Newton per millimeter square. I is the moment of inertia, depending on the cross-sectional area of the beam, which is 2 centimeters width and 6 millimeters thickness. Okay? هلا I will repeat هاي equation بس تقري لنا deflections between 0 and L over 2. The others حتى وقت تكتبوه على الاكسل شيت وين مكتوب عندكم X بتحطوا L minus X اللي هي 800 minus X to get the mirror. اوكي؟ فإذا بس نوصل بدنا نقرا deflections على 500 و 600 و 700 هونيك بالايكويشن بدل الاكس بتحطوا 800 minus x لحتى بنكون عم نقريها and prove it experimentally. Now we will start. هون بالتيبل حطيت لكم انه بنبلش على 50. We will not start at 50. We will take at 100, 200, etc. up to 700. هلا I will explain a little bit what will happen here in this experiment. This dial gauge will read how much the system deflected downwards. أنا دايما I must have in the back of my mind that I have to bring back the system to its initial level. ما فيني اشتغل بالسيستم هو inclined. Okay? That's one thing. Because steel is rigid, okay, once I bring the system back to level, the whole system will go as well upward. فin the first place بقرا قد ايه بيعطيني this dial gauge that will be reading the deflection. هيدا رح يقرا لي الديفليكشن. هيدا رح يرجع لي السيستم back to its initial level. فاذا انا بدي اقرا deflection at this dial gauge. However, when I will bring back the system يعني بيكون هون let's say عندي deflection let's say 200 division. When I bring it back to level رح اخسر شوي. Okay, so I have to deduct a little bit the amount given by this dial gauge. هلا I will explain it on the spot. فإذا عندي at x equal 100 والload at mid span وهو 20 newtons. I have to read deflection at x equal 100 millimeter from the left support. هيدا على 400. I guess it is over here. Let me check. This is 400. Okay, let me check. This is 400. هيدا على الميد سبان. اوكي. وانا بدي اقرا deflection at 100. هلا عم حط deflection at 100. This is deflection at 100. اوكي. هلا هيدي بنحطها 0. هلا our great friend رواد anyway مول هيك. هيك احسن شيء، خليك هيك ما تحرك، تقدر تمد ايدك لهونيك. Okay, now I will record first how much deflection is in this dial gauge. Okay, and when we bring the system back to level رح تشوفوا انه هاي رح ترجع لورا. We will be going a little bit upwards. I have to deduct it from the values. هلا شوفوا this، خليك انت هون، خليك هون واضحين.
Yes.
هلا شوفوا هاي عم تقرا لي ديفلكشن. هاي قطعنا، بس نمشي ونوصل نقطة على الزيرو نكون قطعنا 100 ديفيجن. قطعنا 100 110 120 130 140. خليكم هيك 140 ديفيجن. اوكي، فاذا اتفقنا انه هيدي كانت على الصفر برمت 140 division. Now we will bring the system back to level to its initial using the knob. شوفوا هون رح تنقص. شفتوا كيف عم تنزل؟ عم بتنزل. هلا انا هون رجعت السيستم باك تو زيرو، وهون رجعت 10 20 30 38 ديفيجن. فبيطلع عندي 1 او 2 ديفيجنز. بتعرفوا انه الديفيجن هو 0. الديفيجن هون اذا ملاحظينه الديفيجن 0.01 ملم. فاذا بضرب 102 ديفيجنز تايمز 0.01 بتطلع مع الديفلكشن at this point having 20 newtons in the mid span. Now خليك هون. Now I will bring the whole system back to level. بعدها واضحة.
Yes.
Okay. Now I will read at x equal 200. هلا بعد شوي الحق هيدا